Okay, hey guys. What we're going to be doing this lesson is we're going to be solving these radical equations now. If you're part of my math 20, or sorry, physics 20 class, you'll kind of have a bit of an advantage on this part. If not, we'll hopefully catch up quick. So what we're going to do is we need to start doing algebra again. We want to solve for x, right? So this first question, I'm just going to write this over here. So, all right, square root 8x plus 2 is equal to 6. What we want to do is get x on its own, right? That's the goal. Doesn't matter what side of the equation. So I'm going to probably try to keep it on the left side of the equation because it's already there. But first thing I got to do is get rid of this 2. That's kind of the thing you want to get rid of first. We want to leave the square root symbol until last. That's kind of the last thing we want to get rid of. Yeah, we just don't want anything kind of hanging off the side there, like a minus or a plus, anything. So we get rid of the 2, and the way we do that is we subtract 2 from both sides. So minus 2, those cancel, and we have 6 minus 2 on that side. So what we have left is square root of 8x is equal to 4. Now the next step, you might think, would be, well, I got the 8 there. Maybe I'll just divide both sides by 8. Nope, can't do it. Stop there. This is kind of trapped underneath the square root symbol. You can kind of think about it that way. We can't get rid of this 8 until we get rid of that square root symbol, or the radicand. So yeah, the way we get rid of a square root is by squaring. We have to square it, but if we square one side, we have to square the other. Whatever you do the one side of the equation, you have to do the other. So the reason why we did that is now that I took the square of a square root, they kind of annihilate each other. That square comes in contact with the square root, and they go poof, they annihilate. So what we're left with is 8x is equal to, and now I've still got 4, but it's being squared now, so it's 16. Last step now, you always want to do the opposite of what's being done. So right now 8 is being multiplied by x. I want to do the opposite, so I'm going to divide both sides by 8. Divide that side by 8, divide that side by 8. And what I have is x is equal to 2. So that's the general way that we're going to solve these questions. So, but then the last thing I'd like you to do is we want to verify our solution. So we got 2 for an answer. What I mean by verify is we're going to start with our original equation again. So we'd say square root of 8x plus 2 is equal to 6. So this would be my left side on here, on this side, on the left side. And this would be my right side. I want to check that they're actually going to be equal if I plug 2 into place of x. So let's try it. So if I go square root of 8 times 2 plus 2 is equal to 6. So this would be really the square root of 16 plus 2 is equal to 6. Square root of 16 is 4 plus the 2 that I had is 6. So yeah, the left side does equal the right side. So got the right answer. So that's kind of the general thing we're going to do for each one of these questions. You solve for it, and then you plug it in to your original equation and check to see if the left side is actually equal to the right side. All right, so let's do the second one. I just want to go through a bunch of these. So this next one, I'll just do it over here. So square root of 2x plus 5, what's happening, is equal to x. So we got a few things to choose from here, right? We'd say, well, I want x on its own, that's the goal. But I've got like a 2 here, I got a 5, I got a minus 1. We know that we got to get rid of the minus 1. I think about it as being just like hanging off the side here. It's like the thing that just is easy pickings. So I'm going to get rid of the minus 1 first because it's not underneath the radical symbol. So I'm going to do the opposite of what's being done right now. So it's being subtracted. So I'm going to add 1 to both sides. So plus 1, those cancel. And what I have now is the square root of 2x plus 5 is equal to x plus 1. Now, again, remember the goal. I want to get x on its own. So like that 5 is there, but it's underneath the radical symbol. Remember what I was saying before? It's kind of like it's trapped under there until I get rid of it now. So that the radical symbol has to be the next one to go. I'm kind of stuck until that goes. So the way we get rid of a radical symbol is by doing the opposite. So it's a square root, so I need to square it. But whatever you do to one side, you have to do the other. And you square the whole thing, right? So squaring the square root, they annihilate each other, and I'm left with just 2x plus 5 on this side. And now on this side, I've got x plus 1 squared. Now what we want to do is get the x's on the same side of the equation is probably the good general goal. But what so many people do, and I don't want you guys to be doing this, is they're going to square x plus 1, and they'd be like, well, okay, well, x squared, and then, you know, plus 1 squared is 1. So yeah, there we go, I'm all done. But that's wrong. Don't do that. We need to rewrite this as x plus 1 times x plus 1. That's what x plus 1 squared is. So we need to make sure that we actually do that, and then we FOIL it. So that times that, that times that, and that, right? Your old FOIL thing. So that's the next step there. So I'm just going to kind of rewrite what I have left here, just underneath. So now I've got 2x plus 5 is equal to, well, that ends up being the first one's x squared. And then x times 1 is x, so plus x. 1 times x is x again. And then finally 1 times 1 is 1. And I'm just going to simplify this right now. That x plus x, that's really just 2x. So make that simpler right now. All right, so now what I got to do is get my x's on the same side of the equation. But something's going to happen that's actually going to benefit us here, is if I subtract, let's say 2x from this side, and then 2x from this side, right? You can do that as long as you do it to both sides. What happens is that these cancel, right? The positive and negative cancel. But then so do these. Positive and negative, they cancel. So I've lost that whole term, which makes things a lot easier. So it would have been a hard problem if we weren't able to cancel that. We would have been kind of stuck. It would have got kind of tricky. We would have had to use like a quadratic equation to solve it. But we don't now. So I'm just going to clean this up a little bit and write what we have left after we cancel those. We've got 5 is equal to x squared plus 1. So now next step is I have to get rid of the positive ones. I'm going to subtract 1 from both sides. Those cancel. So I've got 4. I've got x squared is equal to 4. All right. So easy next step, or you'd think. Got to take the square root of both sides. So the square root cancels with the square, and I end up with x is equal to the square root of 4. And you might be thinking, well, yeah, I know what the square root of 4 is, 2, right? So I might be like, well, easy, x is equal to 2. But remember when we talked about this, x is also equal to negative 2 in that case. So x is equal to plus or minus the square root of 4. So what we need to do is figure out which one is actually correct. One of these actually isn't going to work out very well. And I'll kind of show you what I mean by that. I'm just going to put this down here. So I'll just leave it like that. So it's equal to positive or minus 2. All right, now what we got to do is check out. So first what I'm going to do is check out is I'm going to go back to the original equation. And I'm going to try, well, let's do negative. Let's do the negative 2 first. So let's see what happens. So if I put in, I'm just going to write the original one again. So 2x plus 5 square root minus 1 is equal to x. And then if I go, okay, I'm going to put my negative 2 in place of x there. So we'll go 2 times the negative 2 that I just said the answer was down here, right? Or one of them. Plus 5 minus 1 is equal to x. So what that ends up being is, and by x I should have had negative 2. Right, sorry, that should have been negative 2 on that side as well. Negative 2, negative 2. So I want to check, is the left side of this equation they're going to be the same as the right side of the equation. So if I go down, I'm going to have, well, 2 times negative 2 was, here, let's do it. 2 times negative 2 is going to be equal to negative 4, plus 5 minus 1 is equal to negative 2. That ends up being square root of negative 4 and 5 is 1, which is really just square root of 1 is 1, minus 1 is equal to 2. So in the end here, I've got something that says 1 minus 1, 0 is equal to 2. 0 is not equal to 2. So negative 2, the negative part in this, is what we call an erroneous solution. Sorry, I misspoke there. It's extraneous solution. Erroneous. It means kind of the same thing though, right? Yeah, anyway. Extraneous solution. Extraneous. Wow. My pen's like getting out of the whack here. Yeah, so extraneous solution. Write it down better than I did there. So if we check the other one though, let's just check 2. So 2, square root of 2 times 2, and not negative this time, plus 5 minus 1 is equal to positive 2. And if I fill this out, this is 4 plus 5 is 9. Square root of 9 minus 1 is equal to 2. Well, square root of 9 is 3, so that's 3 minus 1 is equal to 2, which is saying 2 is equal to 2, which it is. So 2 was our right answer there. So x is equal to 2. A lot of work for one little problem, right? But that's where we're at. I'm just going to put that there to show, yeah, the top part was question A and this bottom part was B. All right. I'm actually going to end this video there just because it's getting kind of long, and I'll pick up in question number 2 in the next section there.